This question is taken from the NSAA 2020 Section 1 paper, and it is question 35 of the Physics subsection. So we read, a sample contains one radioactive isotope, which decays in one step with half-life 120 minutes, to a stable isotope. The sample is placed near a detector which reads 910 counts per minute. After 240 minutes, the reading is now 238 counts per minute. After 360 more minutes, a third count rate is measured. What is the background count rate and what is the expected reading in the third measurement? So immediately I noticed with the information that 240 minutes in the first step is 2 half-lives. So we're trying to get its background count rate and the expected reading. So in order to get the background count rate, we'll need to work out the count rate associated with this radioactive isotope and then take that away from the total amount. So the radioactive isotope after 2 half-lives goes down to a quarter of its original amount. So 910 to 238, this must be 672 the drop in the amount of radioactive isotope. So this is 3/4 of the original. So because there's a quarter left, then whatever it goes down by must be 3/4. So then to get a quarter, that must be a third of this. So a quarter is 224 counts per minute from these. So the total count rate after 240 minutes was 238, and we've just worked out that 224 of this is due to that radioactive isotope that's still there, the quarter of it that's left. So the background count rate we can easily deduce is 14 counts per minute. So we needed to get the radioactive isotopes count rate at any one time in order to get this background count rate. Now we move on to the problem of the third count rate and what we expect to measure. So this will come from the background plus whatever is still there after that three more half-lives, which 360 more minutes is. So think of these numbers in terms of multiples of the half-life. And after 3 more half-lives, the 224 that's there must divide by 8, so a half times a half times a half. So this is 28 left. So 28 from the radioactive isotope and then 14 from the background, we get 42 counts per minute in total. So the answer must be H. So we have 14 counts per minute from the background radiation, and then the expected reading on the third measurement is 42 counts per minute. So in the NSAA exams, these techniques come up quite a lot where in order to work out another variable, you'll need to do some intermediate steps. So in this one, we need to find out the radioactive isotope, how much there was of it left, or how much it was contributing to the total count rate, and then whatever was left was the background radiation. Because we know the differences in these count rates will be due to the decay of that radioactive isotope. So we'll have to use that information in some way.